Urgent. You have 40 minutes to design an enterprise architecture from scratch. You are locked in a room and must prove you operate at staff level. The scenario you are given is specific. Design an AI-powered customer support assistant for a retailer handling 1 million active users. A mid-level engineer hears this prompt and immediately turns to the whiteboard. They start drawing architectural boxes, jumping straight into vector databases and model selection before mapping the terrain. To secure a staff rating, you must operate on the meta layer. You dictate the problem's scope, weigh the technical trade-offs, and neutralize system risks before you write a single line of code. We are going to tackle this problem on 2 tracks simultaneously. On the left, we will build the actual technical architecture. On the right, we will track the architectural behaviors that demonstrate seniority in a high-stakes environment. Mastering this dual-track execution, balancing hard engineering logic with strategic communication, is the required formula to pass an enterprise AI interview. Before placing a single component on the board, you dictate the boundaries of the system. You define the scale. The system must handle peaks of a few hundred chats per second. You set the performance target, a time to first token of under 2 seconds, ensuring the user sees the start of a response almost instantly. You establish the absolute safety constraint. The system must have 0 unauthorized data access and make 0 unapproved state changes to any user account. By stating these numbers out loud, you create foundational metrics that justify your technical choices. This proactive scoping shifts the conversation from theoretical boxes to measurable business outcomes. Without establishing these boundary conditions on minute 1, any pipeline you propose later is unmoored from the reality of the production environment. Incoming user messages cannot be treated equally. The architecture requires a semantic router to split the traffic into 2 distinct pathways based on intent. This router acts as a rapid decision engine. It instantly analyzes the prompt to determine if the user is asking for information or if they are requesting a concrete task. Information requests, like checking a return window, are routed down the blue knowledge path. This connects to your retrieval augmented generation pipeline to pull static policy documents and specifications. Task requests, like return my headphones, trigger the red action path. This engages an agent designed to execute account-level operations against internal APIs. You separate these paths because they carry different risk profiles. Answering a return policy question incorrectly is a support failure. Executing a refund to the wrong account is a security breach. Treating an enterprise assistant as a single monolithic pipeline creates friction. The model is often either too restricted to take useful actions or too permissive to be trusted with sensitive account changes. Looking closely at the knowledge path, standard vector search is insufficient for enterprise data. You implement a hybrid search strategy. Pure, dense vector search relies on semantic meaning. It will frequently miss exact critical string matches, like a 10-digit product SKU or an obscure alphanumeric error code. Pure keyword search is equally flawed. If a policy document mentions a power failure, keyword search will completely miss a user typing, "it won't turn on." You fuse both methods for high recall, retrieving dozens of potential matches. Then, a cross-encoder re-ranker filters 50 candidates down to 3. Detailing these subtle failure modes unprompted demonstrates you understand the limitations of standard RAG at scale. Once the context is retrieved, you apply a strict system prompt constraint. The model must only answer using the provided documents. If the context does not contain the answer, it is instructed to abstain and immediately trigger a human handoff. A confident hallucination regarding a shipping policy costs the business money and erodes trust. An honest escalation to a human agent protects both. Over on the red action path, you deploy an autonomous agent loop. The model follows a cycle to process user requests: reason, call a tool, observe the result, and repeat. Because this path interacts with APIs that alter database states, it carries the highest operational risk of the entire architecture. To mitigate this, you establish hard guardrails. Every single tool call must be strictly scoped to the authenticated user's ID, preventing the model from crossing into another customer's account. Next, you introduce a final safeguard for write actions, a user confirmation gate. The agent proposes the action, the user confirms it. Prioritizing the security of these state-changing actions shows operational maturity by focusing on highest-risk parts first. Enforcing this propose, don't act constraint ensures the system fails safe. An unpredictable agent will never leave a database in a half-changed state. With the logic paths built, you have to prove the serving infrastructure can actually hit that sub-2-second latency target we set in minute 1. You implement token streaming. Instead of waiting for the entire generation to complete, you stream words to the UI as they compute, fulfilling the user's expectation of speed. To handle the volume of hundreds of chats per second, you apply continuous batching at the inference layer. This keeps GPU memory saturated and maintains high throughput during peak traffic spikes. Finally, you deploy a semantic cache. When thousands of users ask about the holiday return window, the cache serves the identical answer instantly, bypassing the LLM entirely and saving compute costs. A highly capable retrieval and agent architecture will fail if the infrastructure cannot mathematically support the production load. You have designed a complex, multi-path system, but a senior architect never proposes a big bang release to production. You sequence the build based on value and risk. Version 1 is the knowledge path alone. It delivers immediate deflection value by answering common questions, and the risk of catastrophic failure is low. Version 2 introduces the action path, but restricts the agent to read-only tool calls, allowing users to autonomously check order statuses. Only in version 3 do you activate write actions, like processing returns, strictly behind the user confirmation gate. The interviewer evaluates the sequence of the rollout as a proxy for how you manage risk and deliver value in a real production environment. This is the staff-level standard. You pass the interview by weaving retrieval logic, agent safety, infrastructure, and deployment into a single cohesive narrative, driven by business metrics and risk mitigation. Now it's your turn to apply the framework. Your prompt is to design a personalized LLM recommendation engine for a streaming app. Map your boundaries, balance your retrieval scale, and dictate your deployment sequence.